Dear friends, let us take another example to understand the setting out of a simple curve by offsets or the ordinates from the long chord. Two tangents AB and BC intersect at a point having a chain age 545.65 meters. We are required to calculate all the data necessary for setting out of a simple curve. The curve radius is given as 625 meters and deflection angle 45 degrees. The method which is told to us is offsets from the long chord method. We have been told in this case the chain length is 30 meters. So we are compiling all the data, whatever data has been given. Chain age of B given to us as 545.65 meters. The radius of the curve is 625 meters. The deflection angle is 45 degrees. The chain length 30 meters. So we are supposed to find the data to set the curve by the offsets from the long chord method. So that's my figure. The yellow line we are supposed to get. Okay, the only red lines we have. Now coming to the calculations, first the tangent length. Tangent length is BT1 which is equal to BT2 given by R tan phi by 2. R is given to us as 625 meters and phi, the deflection angle, is given as 45 degrees. So BT1 equal to BT2 is equal to R, that is 625, into tan of 45 divided by 2. So that comes equal to 258.88 meters. Now length of the curve. Length of the curve, that is this length, the yellow length, is T1 dt2, that is T1 dt2 is given by the formula pi r phi upon 180, where phi is in degrees. Pi into r is given as 625 and phi, the deflection angle, is given as 45 degrees divided by 180. So we get that equal to 490.87 meters. Now what is the length of the long chord? That is T1 E T2. The length of the long chord is given by the formula 2r sine phi by 2. 2r sine phi by 2. So 2 into r, which is 625, into sine of 45 divided by 2. So that comes equal to 478.35. So that means the length from T1 to T2, this L, is 478.35 meters. So that we have calculated. Now, having done these calculations, let us mark the point T1 and the other points. What is the chainage of T1? We know that the chainage is measured from here, and then at this particular point, what is the chainage we have been given? So the chainage of T1 would be the chainage at B minus BT1. So chainage at B is 545.65 minus BT1. This distance has been already calculated earlier as 258.88 meters. So we get this answer as 286.77. So chainage of T1 is obtained as 286.77 meters. Now what is the chainage of T2? Chainage of T2 is chainage of T1 plus the curved length, because we will be coming to T1 plus we will be putting the chain on the curved length. So chainage of T2 is chainage of T1 plus curved length, which is 286.77, that is the chainage of T1, plus length of the curve is 490.87. So the chainage of T2 comes to 777.64. So this chainage over here, the chainage of T2 is 777.64 meters. Going ahead, we calculate the apex distance. The apex distance is distance BD. The distance BD is R into sec phi by 2 minus 1. That's the formula. R is 625 into sec of 45 degrees divided by 2 minus 1. So the apex distance, this distance comes equal to 51.50. The distance BD comes to 51.50 meters. Worst sine of the curve DE is R into 1 minus cos phi by 2. So R is 625 into 1 minus cos of 45 upon 2. So that comes equal to 47.58. So DE, length DE is 47.58 meters. So that has been calculated. Now locating the point E. Locating the point E, if I know the length T1, T2, take half of that and that would give me the length T1E. So T1E or T2E, whatever, T1E equal to T2E, it is equal to half of L or L by 2. So that comes equal to 478.35 divided by 2, which is equal to 239.18. That means from T1, if I measure a distance of 239.18 meters, I will be defining, or I will be able to define the point E over here. Having got this, now let us find out how many number of chains would be, or peg lengths will be appearing over here from where we will be taking the perpendiculars. Now the total length from T1E, this length is 239.18. That should be divided by chain length, which is 30 meters. That comes to 7.972 numbers. So that means we are having total of 7 complete chains, and a small portion of length would be remaining. So we have divided the long chord into two parts, and over here we are going to place 7 complete chains. 7 complete chains would be used. So 7 into 30 comes to 210 meters, and a small portion of 239.19 minus 210, which is equal to 29.19 meters, would be remaining as balance distance over here. Having got this, that means I have got the distance x for each of the values for which I need the ordinates. Now I can prepare the table. So when I'm preparing the table, calculate the offsets to each chain point. To each chain point, I'm calculating the offsets. So y is equal to root of r square minus x square minus root of r square minus L by 2 the whole square. Substitute the value of x. In the beginning x is 0. I get y. When x is 0, I get y as 47.58. When x is equal to one chain long, one chain is 30 meters. So at x equal to 30 meters, put x over here, get the value of y. Y comes to 46.85 meters. Then two chains long, one chain, then second chain long, x becomes equal to 60. 30 plus 30, 60. Substituting 60 over here, I get y equal to 44.69 meters. Similarly, the next chain gives me 90, then 120, 150. Similarly, the last chain over here completes the distance from the point E as 210 meters. At 210 meters, substituting over here, I get the value of y. The value of y comes to 11.24 meters. Obviously, at the point T, the answer has to be 0. Mathematically, it comes equal to 0. So, in this way, we have got all the values at various values of x, all the values of the offsets or the ordinates for various values of x we have already calculated. So we can take the perpendicular offsets from those points, and on the other side of E, we can have a mirror image of that will complete the curve. That's exactly the way we do the setting out by the offsets from the long chord method.